Hello guys, welcome back to another video of Business Analytics Complete course. We are still in basic knowledge and today we are going to continue and complete the statistics topic. Okay, in the previous lesson we talked about the types of statistics and variables. In the future video we will need to know about some basic knowledge, so make sure that you have reviewed on previous topics. And if you are a new member in this channel and would like to follow uh, this course and um, other same business course that you can meet a topic in my channel, don't forget to click on subscribe button and bell. Okay? So, okay, but about today. Measure and central tendency. Measure and central tendency is the new lesson that we talked about it today and in this video. Okay, let's start it. Don't forget to leave me your question. Central tendency and dispersion. There are two kinds of measures. Measures that indicate the approximate center of a distribution are called measures of central tendency. Measures that describe the spread of the data are measures of dispersion. These measures include the mean, median, mode, range, upper and lower quartiles, variance, and standard deviation. So there are various measures. We'll go through it, but broadly, it will tell you what is the average measure of this person. Will tell you what is the variation in the data, like what is the minimum or maximum. What kind of measures? Central tendency and dispersion. Both of them are very useful in describing the data. So there are like two eyes for both the central tendency and the disposition. These are often called descriptive statistics because both the central tendency measures as well as the dispersion are used to describe the data. So that's the reason these are called descriptive statistics. So the descriptive statistics under central tendency are the mean and average. I'm sure you would have heard of average many times in your schools when you are studying the basic mathematics. Here we go through it quickly. The key thing, what we're doing is to use some example while going to these concepts to get a better understanding of it. So, within the central tendency, there are these measures that mean on average, median, and mode, which will be coding in the next slide. The next slide will start with the central tendency and then go to the discussion. And so we'll first go to the central tendency. The next line is central tendency mode. Let's look an example that will make understanding easier. Here we have some numbers. They could be anything. A student, curriculum scores, or anything else. So let's say you are asked to find out more of this observation. So as I said, more is the number which appears often there. Mode is the number which appears often there. What you do to find out the motives. So first, order these numbers. You order it like 3, 5, 7 in the increasing order and then see which of these observation is offering the most. So if you see here 23 only 3 or 4 times, which all others are putting only once. So more is in this case is 23 because it's appearing the most often. So to summarize, mode is the frequently occurring value. That is what is not commonly used in describing the statistics show. But for the sake of introduction, I have kept it here. So let's see one more example here. You are given this data 1, 3, 3, 3, 4, 4, 6, 6, 6, and 9. As you see, 3 is appearing 3 times, 6 is appearing 2. So whenever you have two modes, it is called bimodal. It is called bimodal. It's the only one which is called a single bimodal order. But as I said, is less frequently used. Let's quickly move on to the next. Measure is mean publishing them. I mean, is nothing about adding all observation and dividing by the number of observations. So it's mathematically denoted in this way. Let's look into the example. Um, let's say the vice executive who received the bonus last year and the bonus is like 14,000, 15,000, 17,000, 16,000, and so you are asked to find out what is the average bonus the company has given. How do you do that? The simply sum up all the observations on the top, uh, 14, 15, 17, 16, 15, and divide by the number of observation in this case and 5 Delphi executives. So the average bonus, which is 15.4. So um, so that is the average. So simply average nothing but hiding up all the observation and dividing it by a number of observation. It gives you a metric of what is the average number. I mean that the metric which describe your data simplistically. In this case, the average is 15.4. Some executives got put in some executives about uh, 16 and 17, but on an average 15.4. The next slide, the problem of mean. There are some problems in the meeting, so you can't use a mean. You have to look at closely when you are using them. So we will understand our players are outliers, are or large positive values, are not just negative values, which are away from the other values. So let's take an example below to understand what I meant by it. This is the weight of each professor. As you see, there are so many professors here, and let's just consider the case 1. I mean second column. Uh, the mean weight in case 1 is 194.6. What you see here, the main one. Now, let's say you have changed these two observations. I mean number 3, 189, that convert to 410, as well as under 190, 189, I mean 187, convert to 610. So you have to make these two observations. By changing just these two observations, you can see the mean has significantly increased. just by changing two values. This extent, it seems to be all clear. A simple uh, plot below shows the outliers who you see. Most of the values are in this region between 200 to 300, but there is two values which are quite far. So outliers and the definition is the one which these are the largely positive, all the largely negative value which are away from other values. So it's called an outlier. Whenever you have outliers, it distorts the mean. Therefore, in this case, the mean has increased from 194 to will be just because of um, these two observations. We have to be careful when we have a set of data and we're asked to calculate the mean. The first thing that we have to do is simply assess, are there any outlier in the data or not? And so you can assess the outliers in the data by blocking in a simple uh, plot. So are discussing the next section how to plot this chart. But for time being, now believe that by uh, plotting this chart, you can identify with each other. So we will discuss in the next section like how do you plot this chart so that I will help you to get so when you are using mean, just by just be careful of the object. That is a conclusion from this. Let's move to the next one, which is a weighted mean. It does seem like mean, but we add some weights to each of the values of observation. We are assigned to observation while calculating the meaning that is different. So we had one observation which was taken up positions divided by the weights. For example, this is Julie. She's selling some lemon drinks during a hot Saturday afternoon. In total, sold 50 lemons drinks. She sold 5 drinks for $0.5, 15 drinks for $0.75, and another 15 for $0.90, and 15 for $1.15. So she has sold 50 things, but each a different value. Now you're asked to determine what is the average selling price. Now, how do you do that? Yes, we're using the weighted mean. And as you see, we applied weight of products and finally divided on total amount. So overall, denominator is the total number of drinks sold, and the average selling price of the lemonade drink is $0.89. Different number of lemon things are sold at different pricing. So that is the reason you need to use it weighted mean to identify what is the average selling price. So this is on the mean. To summarize what we have learned, how to calculate a mean. We should have learned that we should be careful to the out there, should be careful about the outliers when we are calculating the mean. Now let's move to the next important central tendency, which is median. So median is nothing but the midpoint of the observation after they have been ordered from the smallest to the largest. Let's take an example. A student's age is like 21, 25, 19, 20, and 22. How do you find the median? So arrange the data in the ascending order. What is the midpoint? Median is the midpoint of the observation after ordering the data. So here, the midpoint is 21. I just giving these examples in details, and if you go to the Excel, if you go to the um, census program, there are many tools to do all this process. What you need, not order nor do all these things. For example, let's take this. The height of the four basketball players are 76, 73, 80, 75. So we arrange the data in the ascending order. Now what is the point here? Since there are only four, the midpoint will rise. Will lie somewhere between 75 and 76. So you have taken a midpoint, which is nothing but a simple average of these two. Let's take the same example which we have seen. These are the views of the professor we have seen before this example, yes? As I said, the midpoint here is between 187 and other one. So the average is 188, which is between 187 plus 189. Now let's take the observation with all clear. So as you remember, we made some change in this example. Palito and Homer, I mean, we had changed in data, and finally we made a 410 and 610. 194 was a mean when our players were not there. It has increased to 248 just because of these two observations. So these two observations have come down here. And so when you see the new median, when there are outliers for the median, it is clear that mean is more sensitive to the outliers, which imply that it changes the mean change. It is clear that mean is more sensitive to the outliers, which imply that it changed the mean change. It was a small review on basic statistics data. We need this review because we are going to talk about data as an analyst, and of course this review is very important to us. In the next video, we will talk about percentile concepts. Okay, it's enough for today. Goodbye for now.